Welcome back so soon, everybody. We are taking a look at section 1.4. Let me scroll up to the top here just to give you where we are. 1.4, where we're solving absolute value equations. Now, we did the notes for this in a previous video, so you can go ahead and click for that. But this one, we are going to be doing the extra practice problems. So let's see, we've got just 9 problems. So we really could do about half of these. So let's start off with, let's do the odd ones, okay? Because I see number 1, and number 1's kind of a juicy problem. And it's interesting to me because you have the absolute value equal to 0. Now when this happens, when an absolute value is equal to 0, there is only one solution. So the only thing you need to solve is 3x plus 12 equals 0. So we'll do that real quick. We'll subtract 12 from both sides. And then we'll divide by that coefficient, 3. And that's going to give us that x is equal to negative 4. And we can graph that over here. We'll just put a dot here at negative 4. That's a pretty sloppy looking dot, but I think you get the idea. So x equals negative 4. That's our problem number 1. Okay. Problem number 3, we've got, well, I'm kind of glad this happened. We've got negative 4 multiplied by an absolute value is equal to 14. Now, in order to solve these, we need to have the equation. It's got to look like the absolute value of ax plus b is equal to c. And if I take a look at number 3, that's not exactly what we have here. Sure, we have an a multiplied by k plus a constant 7 equal to 14, but we also have this number right here, that negative 4. Okay, basically we have a number that's outside the absolute value. So we're going to have to get rid of that first. So we'll divide the left side and the right side by negative 4. And what that's going to do here, that's going to change this negative 1/4 times negative 4. That's equal to 1. So this is basically going to cancel out here on the left. When I do the arithmetic on the right side, I'm going to get negative 3.5. So fully what I get is the absolute value of 7 minus 6k equals negative 3.5. And I'll give you a second here to think about what's wrong with this picture. Do you see it? You've got an absolute value equal to a negative number. That's a problem because the absolute value of anything is positive. So when you see this situation, your correct answer is no solution. So your absolute value cannot equal a negative number. And so you get out of this one pretty quick and easy. Number 3, not too much of a problem. Let's check out number 5. Here's another one that's a problem, and it's the same thing. We need to have the absolute value solved for. So we're going to solve for the absolute value, and we better do this on the side. Okay, taking a look at the side where I have rewritten it again, just zoom in. We've got 3 times the absolute value of 2x plus 5 plus 10 equals 37. And the key for this one is let's pretend that the absolute value is our variable. Okay, we're going to solve for that. So we're going to subtract 10 from both sides. Okay, that gives us to 3 absolute value of 2x plus 5 equals 27. So we'll divide both sides by 3. And that gives us the absolute value of 2x plus 5 equals 9. Now we've already done quite a bit of algebra just to get here, but we're not finished yet because we need to solve for x. We need to solve this absolute value. So let's try to remember what we do here. We're going to start off by writing our equation without any absolute values at all. That's what we have over here on the left side. And then over here on the right side, we're going to write our same absolute value equation, but instead of equaling positive 9, we're going to make that equal to negative 9. Now let's solve the one on the left first. So we're going to go ahead and subtract 5 from both sides. That lands us here at 2x equals 4. We'll divide the left and the right by 2. And that gets us to our first solution, x equals 2. We're not finished yet because we still have this second equation here, 2x plus 5 equals negative 9. And you should find that the solution here on the right side is going to be really similar to the solution on the left side. The first thing you want to do is subtract 5 from both sides. 2x equals negative 14. Go ahead and divide everything by 2. And that gets us to x equals negative 7. So those are our two solutions, x equals 2 and x equals negative 7. If you want it to be fancy again, you can write that in set notation. Okay, that takes care of our number 5. What were those? Negative 7 and 2. Let's go ahead and put our dots there, negative 7 and 2. And let's keep moving. Let's take a look at number 7. Number 7 is that more advanced situation that we were talking about, where you have an absolute value equals an absolute value. So we'll set that up real quick. We'll do this over here on the side again, like always. Okay, so here's our number 7. We're going to make our two equations, and let's remind you how to do that. Start off by writing the equation as if it had no absolute value signs, and then you're going to solve that. And then you're going to write the same equation, but you're going to trade the absolute value signs for parentheses, and you'll put a negative sign in front of the whole thing. Let's solve the one that I've written on the left first. I have two p's, a p on the left and a p on the right. Which one of those are smaller? Well, actually, they're the same, so it doesn't really matter which one I do, or which one I think is smaller. So let's just subtract p from both sides. Let's see what happens here. Now, notice that I've created a zero pair on the left side and a zero pair on the right side. That's highly unusual. That's not supposed to happen in a problem that's normal. And when I do the subtraction, I get the line, or I get the equivalent equation, 4 equals negative 2, which is not true. So at least for this half of the problem-solving routine, we're going to get no solution. Let's see what happens if we try to solve on the right side, this one right here. Well, the first thing we want to do as we solve is we want to distribute this negative sign to the p and to the negative 2. Okay, this time things are different though, because now instead of a p, I'm going to have a negative p. So the smaller of the two, what is smaller, p or negative p? Negative p is supposed to be smaller, so I'm going to add p to both sides. This time I only make that zero pair on the right side, right over there. There's my zero pair. And that's equivalent to 2p plus 4 equals 2. So that's equivalent to, well, no, we're going to subtract 4 to both sides. Now we have an equivalency. We've got 2p equals negative 2. Divide by 2. And p is equal to negative 1. Now, this kind of goes to show that even though we only have, even though we got a no solution on one part of our problem solving, we still actually have a solution because of the second half of the equation where p is equal to negative 1. And guys, this is where we're going to end up for today. Good luck with your problem solving, and we'll see you next time here when we do more algebra.